Assalamualaikum warahmatullahi wabarakatuh and very good morning to my panel. I RTS Muhammad Shahrin Amri bin Muhammad Noor and TS Shahriza bin Saad. Thank you for spending your time to watching my Bachelor Degree Project 2 presentation. Okay, first of all, I would like to thank to my supervisor, which is Dr. Muhammad Shahri bin Muhammad Isa, for his advice and support in order to finish my project PSM2 very well. Okay, so first I will introduce myself. Okay, my name is Nur Najwa binti Ahmad Sabri and my matric number is B08181010180 and I am from 4BEEE S1/2. So my title project is Development of IoT based Smart Aquarium System. Okay, for this video presentation consists three parts, which is introduction, poster presentation, and project demonstration. Later, I will show my poster presentation and I will explain one by one inside my poster. Okay, these are my poster project. So in my poster project, I include with introduction, objective, methodology, result and discussion, conclusion and reference for my project. Okay, later I will explain one by one for this subtopic. So, firstly is introduction. This project presented is development of IoT based smart aquarium system that can automatically control and monitor by using ESP32 microcontroller and blink application with Wi-Fi connection and Wi-Fi internet. Taking care of fish can be challenging job since you will need to monitor the environment of fish in terms of water quality and temperature that's suitable with them, giving them a food on time and need to change the water if the water become cloudy. If we do not take full attention, maybe the lifespan of the fish not last longer. But these are for the species of fish. Not all fish need full attention. Okay. Next, my objective project is first to create an IoT-enabled smart aquarium that will make fish keeper easier. Second, to build an aquarium system with features such as automatic water refill, automatic food feeder, automatic lighting, automatic filter water, monitor water quality and temperature of water with low cost equipment. And the third one is to develop a smart aquarium system that can be operated easily via mobile application using ESP32 microcontroller and Wi-Fi internet. So for my methodology, this is my block diagram for my project. So for the input port, I have used power supply 20 volt 12 power supply 12 volt and interface IoT blink application with Wi-Fi connection. Okay, second microcontroller that I have used in this project is ESP32 board. Okay, for the output, the component that I have used is servo motor for feeder, motor driver to control a DC 12 volt water pump A and water pump B. Water pump A for automatic refill water, water pump B for automatic filter water. Okay, next, float water sensor to detect the level of water. Next, using turbidity sensor to detect the water quality in the tank. This turbidity will trigger the water pump for filter water. Next is ADS 18B20 temperature sensor, and lastly is using light and PIR sensor for the output port. Okay, this is my general flowchart for overall my project. So my project have two phases, which is phase 1 and phase 2. For phase 1, I have designed circuit project for electronic part and hardware part. Next, test and run code for each features, like I state in my objective. For features for automatic review water, automatic feeder, automatic lighting, automatic filter water, test for turbidity sensor and temperature sensor. So next is phase 2. Phase 2 is which is first put an IoT Aquarium system. Next, I will compile the code into ESP32. So if there have error, modify code and run test again. If there are no error, it just takes success, implement IoT Aquarium system into hardware project. And after that, I can run the project, my project system. Okay, so this is my result and discussion. Okay, this is my interface in Blink application. So this is a show for to set the time for food feeder. So time 1 for day morning, time 2 for day afternoon, and time 3 for day night. So if you want to set 2 time to giving food to fish, it's okay. You can set, you can choose whether time 1, time 2, or time 3. So next is this is to display the temperature value, and this is for to display the turbidity sensor value. So this is for the LCD to display the comment from for the output automatic food feeder, automatic refill water, and automatic lighting. So this is my project hardware. So this is for filter water pipe, and this for automatic food feeder. So this is my power supply, 12 volt circuit power supply. So this is LCD to display the turbidity sensor, and I have 3 indicator light, green light for automatic for running automatic refill water, and the red light for the to detect the cloudy water, and LED yellow to detect the clear water. So this is my project at night. So if my PIR sensor detect movement around the tank, LED will turn on. So for the conclusion of my project, first, the objective of this project is achieved. Second, this simple project system can maintain the fish environment in tank using low cost equipment. The third one, Internet of Things is successfully implemented to the project using the application. And lastly, this project help the user to control and monitor easily and reduce manpower and time when using this system. So for my reference for this project is I refer to K. Fasha Muhammad Daud, which is the title is an IoT based smart aquarium monitoring system. So that's all for my poster presentation. Later I will do the demonstration for my project.
First step, we need to on the power supply and then connect the ESP32 with the Wi-Fi connection. After that, the project will function. So my first features in this project is automatic refill water. So for this automatic refill water, when the level sensor in the low state, the DC motor will turn on, and when the DC motor is running, the indicator green will blinking. So this we took 3 minutes to refill the water at level that we have state. So if the water level sensor in the high state, it will turn off the water pump motor and indicator green will be turned off, and all these will be shown in LCD at blink application. Next features in this project is automatic food feeder. So this automatic food feeder, we drop the food into the tank according to the time that we set in blink application, which is time 1, time 2 and time 3. If the clock show at the time that we set, the servo motor will turn to 90 degree, and the food feeder will open and then drop the food into the tank. After 26 seconds, it will close the food feeder again. So this will display in LCD at blink application. Next features is to monitor the water quality and the temperature in the tank. So if the turbidity sensor detect the value below 25 or equal to 25, it will show water clear and the indicator yellow will turn on. If the turbidity sensor detect show the value above 26, it will show water cloudy and indicator red will turn on. After that, the automatic filter water will turn on. So this value will show at the blink application. Lastly, automatic lighting at night. If PIR sensor detect of movement around the tank, LED automatic turn on. If not, it will automatic turn off.